Hello, my name is Chris Williams. I'm a principal engineer at Expedia. Here today to talk about how Expedia leverages Graph, how we implement and support infrastructure related to Graph and Neo4j at Expedia. I'm joined on stage today with my colleague Raghu. He'll be talking about the infrastructure piece. I'll be talking about the implementation part. We work at Expedia. We believe that one of our missions is travel is a force for good. Right? We want to empower global travel for everyone, everywhere. And you can see we have a lot of brands, right? And this is an interesting slide that you'll need to keep in the back of your mind, because this actually adds to some of the engineering problems that we can solve with the Graph database. All these brands bring all their stuff, right? So Expedia's acquired a lot of these through purchase, and they had their own reservation systems. They had their own set of users. They had their own set of inventory, right? And that has led to some interesting data problems at Expedia. This is another slide to keep in the back of your mind. We have a lot of data, tons of data, heavy data gravity at Expedia. And so I'm going to bring up my colleague Raghu to talk to you about how the infrastructure piece is managed.
Hello. Hi, hello everyone. I'm Raghu Sayana. So my team at Expedia, we manage all the data store provisioning and management. So we have like 10 plus data stores that we currently support and manage, like Neo4j, Cassandra, MongoDB, most popular open source data stores we support. Along with those data stores, we also support AWS managed ones like DynamoDB, Elastic Cache, Neptune DB, Aurora. So in order to help provisioning all these, we built a platform, database platform. And this platform currently supports provisioning of all the clusters across Expedia. In the upcoming slides, I'll show you what is architecture that we follow to create this platform, what are the benefits that we have gained, and what features this platform supports. But before that, here are some of the challenges that we were facing prior to this platform build. So as you have seen, the Expedia, we have several brands. So there are thousands of clusters that we have to manage across 100 plus AWS accounts. And all these clusters, they were provisioned by different teams at a varying automation levels and with people of different DB skills. So the problem here now is it's not synchronized across, and we are not sure if all the best practices are getting applied. And we have problem with governance. Some of the mandatory tags that we use for license tracking and all are not getting applied. So we have that governance problem, and also we have license management problem. We are not sure if we are overusing the license or underusing them. So we cannot quickly get what is the number of licenses that we are using. And also we have inconsistent tooling, which means that the monitoring tool that we use, the logging tool that we use, they are different across all these different brands. So in case when there is an issue, we couldn't quickly resolve that issue because of these inconsistencies. So having all these challenges, we want to solve this problem and give developer a unified experience where they can self-serve, provision the data stores. In most of the applications, it is more than one database. And also not to worry about any of those database management. It has to be completely managed by the ops team. So that's where we created this platform called Cerebro. In short, Cerebro is like fully managed self-serve database platform that's allowing our domains to create products, high quality products, without need for any database management. So these are the features that our current platform supports. It supports single-click provisioning, which means that all that users have to do is just fill out a form with some of the mandatory fields like what's the cluster name, what's the size they want, and that's it. Within 15 minutes, they'll have that cluster available. We also developed APIs where they can integrate those APIs into their CI/CD pipelines, and whenever the application is getting deployed, the database is automatically provisioned. The other important platform feature is it is highly scalable. So whenever there is a new AWS account that needs to be integrated, we can quickly onboard that account onto our platform within minutes. And similarly, if there is a new data store that application team needs, with a minimum development effort, we can quickly onboard that database onto our platform. The other important feature I want to highlight here is the self-healing capability of our platform. So if the node gets terminated for whatever reason, maybe because the node got hung or bad health check, or maybe AWS wants to terminate that node because of the maintenance, the new node will automatically come up with all the existing, with that particular database, and it has this, it can join to the existing cluster. In most of the cases, it will attach the EBS volume from its last instance and integrate it and joins to the existing cluster. And everything this happens without any manual intervention. So nobody's losing sleep over it. So nodes can get terminated at any point of time in the day, and there is no manual intervention required. All the best practices are applied across all the databases now because we have a centralized team and DB experts to do this. And there is automated backups that are happening on all the data stores. And developers can also choose the frequency of these backups. So these are all the features that we have developed in the platform. Before going to the architecture, I just want to show this slide on how we solve the scaling problem. This might be unique, or many of you might have had this problem where we have hundreds, I think close to 150 AWS accounts that we have, and our products needs to be there in all these AWS accounts for the users to provision. So this is the initial problem we were facing when we are designing this platform solution. So we were able to work with AWS, and we are able to use AWS Service Catalog to solve this problem. Does anybody use AWS Service Catalog? Okay. Yeah. So AWS Service Catalog, it creates and it organizes and it governs all the AWS products. So it's a nice service that is provided by AWS, and it works in a hub and spoke model. So you can do all your development in the hub model. You can create your products. So anything that is CloudFormation, you can wrap it and you can create a product out of it. And you can seamlessly push all these products into all these spoke accounts. So spoke accounts are all these AWS accounts where customers are using. And as soon as we push the product is readily available, and users can use this database of their choice and use this provisioning. To just put into perspective of Neo4j, so let's say if we want to release a new version of Neo4j, so we have already created a pipeline using CloudFormation and Jenkins. So all you have to do is create a CloudFormation for Neo4j new version, and just push it into your GitHub, and that's it. The CloudFormation runs, the Jenkins runs, it's pushed into S3, the code pipelines run, and it is there in the Service Catalog, and Service Catalog takes care of making that version available across all the spoke accounts, and it is quickly available for the users to consume. And this is the architecture. This is the complete platform architecture we have. So this is what I just talked about, the Service Catalog, where all the products are seamlessly getting pushed to spoke accounts. So once they're available in the spoke accounts, we use Autoscaling Group to provision all the EC2 instances and to create all the clusters. Along with this, we create other bunch of them like load balancer and other stuff. So when these EC2 instances are getting provisioned, we have an internal agent called Cerebro agent that comes up, and it has all the logic of creating a cluster or joining to an existing cluster, doing all the maintenance backup. It has health check also included in that. So it's continuously running on the EC2 instance and doing all that management for us. And once the cluster is created, we do end-to-end management, right? So we push all those metrics. We use logging tools, monitoring tools for all the metrics. And then we use those to do the pager duty as well. So we have alerts configured on these monitoring tools so that whenever there is an issue in the database, we are the first ones to get notified, and we'll be quick to fix it. And this is the hub. So this is where we pull all the data into our hub. And this is kind of the ops manager for us, where all the inventory is pulled into one single hub account. So we use this inventory to do all the management at the later point of time. Like, we can quickly go through what is the cluster status, how are the nodes behaving. If we want to run patches, we do it from this hub account. Similarly, if we want to do version upgrades, everything we can do it from a single account. So we have a Cerebro UI that is developed, which is making it happen. Some of the tools that we use for that is AWS Systems Manager, which allows you to remotely connect from one single account to multiple AWS accounts. We recently published the blog on AWS, giving all these technical details on how we did this setup. Below is the link here. We also have this same link at the end of the session. So yeah, feel free to browse. So on the broad, we were able to achieve security, governance, and increased productivity. So now all the databases by default are secured. We are doing encryption on the volumes and even in transit. And we have restricted provisioning to certain individuals. So security we have given a top priority to the security. And now governance, we are able to do governance. We are able to enforce all the best practices. We are able to put launch constraints. So we have restricted provisioning to only certain instances in case of Neo4j because it is memory intensive. We want users to only use certain R5 instances or like that. So we are able to consolidate that, we can even disable old versions. So if we don't want any buggy version out there, or if it is end of life, we can quickly go to service catalog and turn off that version, and that version is not available for users to provision. So we were able to achieve that governance, and most importantly, increased productivity. So why I mention this is now users, developers, they are not waiting on others for the clusters to get provisioned. They want to do a POC, they can quickly go to our tool, provision all the data stores they like, they can do that POC, and they can take it to the production. And in case of production clusters, if there is an event that they want to scale the cluster, they can do themselves, they can plan, and we have completely made it as frictionless. So these are all the benefits that we have achieved, and with that, I'll hand over to Chris for the Neo4j EDV use case. Thanks.
Thank you, Raghu. Yeah, so what Raghu and his team have done is they've removed the administration from Neo4j. So as I'm a part of the engineering team, and we don't have to think about that, right? So this helps us go faster. That's a great thing. And that's what we want. No friction. We want to move faster. So I taught a database class. I have a degree in geology, if you can believe that. And I taught a database class, GIS, Geographic Information Systems, at the local community college here for a number of years. In that, I tried to, every lecture I wanted to give people, let them know they can do this, right? You can do this. This is not out of your reach. These things can be done. So I'm going to start with some theory, some industry standards, if you will, some practice that is widely accepted. Then I'm going to show you what we'll call a North Star. And then you and I are going to work through a use case, right? And we're going to build something together today, right now. All right, so that's the pattern we're going to follow with me right here. So there's those three things I just talked about, right? And we're going to test it out and build our own data model. So here's our pattern we're going to follow, the strangler pattern. Is anybody familiar with this? Have you heard of this? right? So this is a great way, if you're on-prem, this is a great way to get out in the cloud, right? So you basically enable change tracking on your data store. You throw events out into the cloud. You create a new data store in whatever you want out in the cloud. You can move your app out there to read, and you slowly strangle your traffic from your old system onto your new system. That's why it's called the strangler pattern, right? So it's a way to move from on-prem out into the cloud. It's also a way, if you have a ton of brands, to bring things together, right? To bring all those brands together in a unified store, right? So strangler pattern works at Expedia on a number of levels. So that's the theory that I want us to hold on to. Right? And then Raghu has a similar slide, right? We have lots of data technology. Expedia is a SQL Server shop. You may know that Expedia was founded by people from Microsoft, right? HomeAway, one of the bigger brands that Expedia bought, is a SQL Server shop, right? There, Hotels.com, SQL Server shop, right? So there's a lot of, we started in the old on-prem days. These older brands have that old baggage, if you will, the legacy stuff. So we know that we started using and picking up NoSQL technologies, Mongo, Cassandra, Aurora, and Neo4j, right? It's all part of the stack that you kind of have to implement and grow with if you're going to move to the cloud, right? So let's talk about the pattern we want to follow. This is our North Star. So we have all these sources. Now, holding on to strangler pattern, we want to enable CDC on all these. And we want to create a change stream on all these sources. It's easy to do. My buddy I just met, Alex Wolford, he has a great presentation I was at right before lunch, streaming Kafka to Neo4j. This is exactly what we do. And we've been doing this for a long time. We've been doing this for 5 or 6 years at Expedia. So we're kind of experts at the old school way of doing this. He's got a lot of new cool things to show you over there. So he's the expert. I'm not going to dig into this. I have a couple of slides later that I'm just going to touch on this and move right through it because I want you to go look at his presentation. That's the thing to do, right? Long story short, you need to enable CDC and get, Debezium is the industry standard for doing this, right? Kafka Connects. They're a way for you to not have to build these. We built all this stuff on our own way back in the day. This was before that stuff existed, right? And so we want to enable a change stream. We want to throw that into some queue, right? Some messaging bus. We call it, a lot of times it's Kafka. We rolled our own. We did our own thing for a while, and then we got on to Kafka after some period of time, right? Our own thing we called Photon, right? It's a Cassandra ring. Then we want to process that change, and here's where the crux of my talk is right here. The pairing of Neo and Mongo. Adding those two pieces of data technology together is priceless, right? And oops, wrong button. So we create a thing we call the entity key graph in Neo4j, right? That's a key piece of what I'm about to talk about. And then we slap an API on the top of it, lets you render your view of data, your slice. And we'll talk about views and slices in a few minutes, but I'm just giving you this North Star real quick. We call these three pieces together, Mongo, Neo, and the API. We call it an event-driven view, right? That's a main piece that we use for this. All right, so let's keep all that stuff in mind as we move forward in this presentation. So these are the two slides that I was like, should I keep these in? Should I throw them out? Should I keep these in? Should I throw them out? And after watching my buddy Alex's presentation, I should throw them out because you go replace these two slides with that. Long story short, these are Java classes that basically grab, you can see the merge statement starts right there, and create prepared statements that throw stuff into Neo and then there's a set and unset, I think on the Mongo part that throws stuff into Mongo. If you want to, that's for real-time data, right? You're streaming data into your graph and into your Mongo. If you have historical data that you need to load, the best way still is through command line and create a S3 of text file, CSV, and drop it into S3, and then load it with these parameters here, right? And so you just create your nodes, and then you create your relationships, and this is the merge statement to create the relationships. All right, so that's great. So now we know how to stream data, and we know how to backfill it if we need to backfill historical data. So I want to invite you on a trip with me, and let's brainstorm a few let's come up with some of the entities that we might use if we were going to build a company that Expedia might buy, right? Or be on my team for a little bit, right? Whichever way you want to look at that, be on my team for a little bit. And let's brainstorm. We're Expedia. We have a website. What does a website mean? What do you have to have? Okay, you have to have traffic, right? And what does traffic come in the form of? Users, right? Requests from users, right? So you have users. What kind of users, if you're a travel company, do you think you have? And you're a marketplace. You're trying to bring together people that are buying and selling something, right? Yeah, right. So owners is our suppliers, right? And then travelers is our purchasers, right? The people buying stuff, right? So I'm not giving away like company secrets here because I think we can all kind of come up with this on our own, right? And then we have things that we're trying to sell, right? Let's narrow our focus. Let's just stay in the vacation rental space because it's the hottest thing in travel right now is vacation rentals. So let's just talk about those. So we're talking about properties and or listings, however you want to look at those things. Right? And then to make it attractive, to make people come to our site, maybe we want photos, right? Maybe we need some text around things, headlines, let's call it, right? Great property with blah, 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 right? And then we might want to have amenities, like things that make that property attractive to certain individuals. Does it have a hot tub? Does it have a hair dryer? Can I bring my dog? Those kinds of things, right? And then the thing we're all after is the sale, right? The bookings. We want to create bookings or reservations against those properties. To do that, we need a calendar. We need like dates. I don't want to stay there at the same time as really any of you, right? And you don't want me to stay in there either, right? You want the property all to yourself. We're not Airbnb. We sell the whole place, right? Not just a couch. All right, and then the thing that makes it go boom is the payments, right? So we want payments. So let's just take a quick second and let's model this out. We have our owners, and they're related to properties, and they have photos, headlines, and amenities. And then they also have calendars, and then we have a reservation, and the traveler creates a reservation, and they start to make payments on that reservation, right? What does that look like to you? Yeah, it starts to look like a graph real quick, right? And what have we done? Well, we've done nothing, right? All we did is model it in the old relational way, right? We're not, and this may be, you may think I'm a Luddite because I use my graph in a relational kind of way, and that's fine, but it works, right? So as a basis, as a starting point, our graph is just the keys between those relational pieces, right? And so my colleague Chakri, who's in the audience here, he said, hey, you should demo this. And it's a good thing I didn't because the demo is not on this laptop, right? But I basically created some dummy data that, here's our create statements for all our owners, listings, photos, headlines, blah, blah, blah. You can read those things, right? And then I executed it. I ran this in Docker. I'm just using Docker on my laptop, running Neo4j, and then I get into the web portal and I execute these statements, and then boom, right? Here are my nodes, right? I start to build my data set as we're walking through this use case. All right, and then I need to create relationships between those things. We already showed that they're related in that one graphic that I had up. And then boom, I execute those statements, and now I'm related. Now I have relationships. Now I can answer questions. Now I can start solving business problems with my graph, right? Because now I know that things are related. All right, and then so this is just for completeness. I can't run this. I'm running Community Edition on my laptop, but if you're running Enterprise Edition, I added this slide for you. You can add your constraints and make node keys out of everything. That's best practice. So that's one half. Remember the EDV piece is the pairing of Mongo and Neo, and this is a classic pairing. You'll find white papers and use cases that have been doing this. One old one is Zephyr Health. They have an old use case that they've paired Neo and Mongo together. This is a very common pairing of Neo and Mongo together. So here are our Mongo statements, right? I'm just I've already created what are they called? Not tables, but collections, sorry. Had a little mix up there. I already created the collections, so I just need to execute these to create my documents inside there. There's a couple of places I want you to pay attention to. One is the property stats. The rooms is 3. and the sleeps is 10, right? So we created a listing, and it has maybe 3 bedrooms, 2.5 baths. It sleeps 10 people. It has a garage, right? And then another one is the photos, right? So we can have more than one photo. Again, we want this to look really nice. We want people to come and stay there. And then one more is amenities. Now there's an amenity key. I just made this up. I have no idea what A, B, F, and M mean, but they're true. We have those things, right? That's an array, and we have those. We can search against them. We can start to make inferences and maybe even market to people if we ask the right questions. Then there's the one that makes most sense, pun intended, is the payments, right? So now we can start to see payments against that reservation. So in Mongo, I've executed that, and then you'll see that Raghu and I own the property. High five, buddy. We're owners together, right? So now, just to show you that I did execute those in that collection there, and you'll see owners is now Raghu and myself. We're going to make some money. So I want to firm this up, and I'll show you how the view is rendered. We're going to talk about this concept of what's called a root key, or you may call it an anchor, right? So you can come in with a key in the graph. You query the graph, you get the chain, and then you can go over to Mongo and by key, grab all the bits that hydrate that view in Mongo. And so this is just a match query that you'll run inside your view, your API would run inside of Neo4j to get the graph that you're after. You start with a root key, you say where owner is whatever ID, and you grab your graph, and then you jump over to Mongo, and you use the second part of the query and grab all the pieces and hydrate your view, and so now you have a full payload for that particular view, right? One thing to remember here is that because our graph is very lean, there's nothing but IDs in it, right? I don't have any extra stuff in my graph. I can jump straight over to Mongo. It's also on the same key. The collection in Mongo is on the same key. So now I'm on the underscore ID of Mongo. That's the PK of the collection. I don't need any other indexes or indices to make this work, right? This works because that's the way Mongo works. There's no extra overhead here. I don't have to manage any of those kinds of things. And because of that, it's very scalable. So now we just add a new collection, have our new query, and now we're going. We don't have to add, you have to tune this. There's no tuning. It's the way Mongo works, right? So that's a pretty large benefit. And you can query the collection simultaneously. That's something to keep in mind as well. So let's look at the graph in practice, because this is really the nuts and bolts and the thing that I want to show you. So in Alex's presentation, he had a good statement, is like, a graph is useless unless you start with the questions. So let's start with the questions, right? So one of the questions that we might ask is like, how many rooms does an owner have? If I'm an owner, like room nights is a thing that people report on. I'm a database guy, I don't really understand the business side, but that's one thing that people might report on is room nights, right? How many room nights can this guy, this person, support in our infrastructure, in our ecosystem, right? So we can do that easily by starting with that owner node and jumping down into all the properties they own and grabbing that stack, right? And then using that key to jump over to Mongo, and now we can do some analysis. We can grab all the payloads, sum up all the room nights, all the rooms that they have, and start to do some real stuff with this, answer some real business questions. So I have a set of these that I want to go through with you. Is my listing available on that day? All right, let's see if our graph can answer that question. So I'm an owner, I want to go to my listing, right? And then I go to my calendar. Seems like, and then I'll have to use that graph and jump over to Mongo again. I can do my analysis, yes or no. It may or may not be available on that day, right? Another one would be, does an owner have a listing with a hot tub? I like hot tubs. I want to stay in a place with a hot tub, right? Usually I like hot tubs because when I vacation, I work harder than when I stay home, right? So I want to be able to relax in the hot tub at night because I've hiked or done something or skied or done something where a hot tub is a nice thing, right? So again, start at the root key of owner, and then jump to listing, and then jump to amenities. And now I have that part of the graph. I jump over to Mongo, and then do my analysis. Is that amenity piece, A, B, F, I don't remember, I made up stuff. Let's call it M. Is M there? Yes or no, true or false? Yes, I can do that analysis, right? Another one might be, what are the frequent amenities of a traveler? So let's say Raghu travels a lot. He always stays in a place where you can bring your pet, right? And so we can do that analysis and figure that out. If we should market to Raghu places that have pets. It's useless to send him things that don't have pets. So he's a traveler. He jumps over to his reservations, jumps back to his listings, and now down to his amenities, right? So we're answering questions. The one graph, right? One graph is answering all these questions. How much money have I made, right? That's a good one. So if I'm an owner, I go down to my listing, I go to my reservations, and then I can go and see how many payments have been made. It's be like your stocks, right? You just be up today, down tomorrow, up today, down tomorrow, right? You can see how much you've made. And then another one, if you're doing maybe you're doing listing quality or some kind of quality check against your piece, right? You can say, how many photos does a property have, right? So we can start at properties and we can run through the photos side and say, hey, this one only has one photo. Maybe that's why it's not getting enough traffic, right? So the important thing here is that one graph powers all those answers, right? I don't have 14 graphs and 14 views. I don't have 53 views and 53 graphs to go with it. I have one graph, answers all the questions, right? And a view is a slice of data with a question behind it. So it depends on what part of the business you're from. You can utilize our graph, right? One graph powers all the views. Each view has a root key. This is important. And it wasn't always, a lot of times it was owner. Sometimes it was listings, but it was other things too. It could be the traveler. It could be, it could be other places that you jump into the graph. Wherever you jump into the graph and the ID you come in with, that's your root key. That's what we call root key. And then again, no extra indexes are needed because we're on the underscore ID of the collection in Mongo. Super fast queries. And so the key concepts here, I'm going to wrap this up and leave some time for questions if there are any. We've discussed and leveraging industry standards as a basis for our solution, right? So we use Debezium, we use Kafka Connect, we used a starting pattern of Strangler, right? And so we're using these things that are well established. We don't have to manage, we don't have to spend a lot of development time building those things. They're already out there. We just have to harness them. One graph, many views. That's a key concept. So as we push the changes in the old systems to our graph, they're updated, and then that graph lives out in AWS, and that can be queried and harnessed out there. And so we don't have to come back. We can slowly strangle our traffic off of the old system and onto the new system. And we've built a flexible, scalable solution. It's easy to add things. And industry standard ways to consume that change and backfill data sets, right? So we're using, like I said, Debezium, and we're backfilling with command line stuff. And then we've created an API-first approach. We slapped an API on it. Now, there's a bunch of ways to enhance this, right? So one pro tip is that we've come up with is first time we built an EDV, we said, okay, there's the EDV, and we shipped it to those people. And then we built the next EDV, and it was like the same exact nodes, right? It was like the same, you want listings, you want this, you want that. It's the same core stuff, and that's why we're like, this is dumb. Why are we constantly building the same EDVs with the same core things? And that's why we came up with the idea of a common view, a common graph, right? One graph for everything, and it works great. So that's a pro tip from that is if you have a very chatty system, go to Mongo first and then come off of that for Neo, right? Because Mongo dedupes for you, right? Mongo only writes to its change, its CDC, if there's actually a change. So if you have a very chatty system, and that's one thing that in the old days of Neo, the early days of Neo, 5-6 years ago, that's not really that early, but when we started doing this, Neo would succumb to that pressure. And so we had to find an engineering way around that. The way we did it is if you write to Mongo first, it dedupes for you. So if you have a chatty system that always writes the same stuff, unfortunately we have some of those, right? And so Mongo will dedupe all those changes. They're not actually key changes. You don't need to record that in Neo. And so you get that for free if you go to Mongo first, and that dedupe is invaluable. right? So now only real key changes that are actually in the system will now propagate to Neo, and those are the ones I write. Everything else is just read, read, read on top of that. And then one last thing is you can set up a cache in between your API and Neo and Mongo. And so create a second change stream. I didn't think I would have the time to get too far into that, but you can set up an elastic cache that sits in between those, and that way the API reads the cache and not queries the database directly. So it's pretty easy to do. Once you get into this, you'll find you'll make the same steps that we did and do that. But for us, this has really been a nice addition. It's a way to bring a bunch of, if you think about back to our brands, all those brands come with reservations. All those brands comes with users. All those brands comes with their inventories. And this, if you set up Neo4j and Mongo right, you can start to funnel all those into a single data store and quickly unify your platform that way.